Hi, guys. I am going to record this video for section 11.4, population density. And I tried to make it look like I was there. See the background? That's my classroom, our classroom. Hopefully I'll be able to convey everything I want to convey as if I was there, and you'll be able to do well on your homework, and I'm checking it next class, okay? Don't forget also to finish your EOC review, and everything that's pending for me to go over, I'm going to go over with you next class. Okay, so let's go ahead and get started. Today we're going to be doing section 11.4, which is population density. So I'm going to share my screen. Also, I'm going to request that the substitute, hopefully it's Miss Williams, has the form, the paper to give to you that has some class examples I'm going to be referring to. So if you want to pause this so she can pass those papers out and then restart it, that would be great. Okay, so what we're going to do is population density is just an application of area. We've been reviewing area recently, area of a circle, and we've done area of other polygons before. So now we're going to use a real world application. Basically, population density is the number of people in a certain amount of space. It doesn't necessarily have to be people. It can be other things like population density of animals in a forest, how many fish are in a lake, things like that. But in this case, we're going to be talking about number of people in a certain amount of space. So whatever the space is shaped like, we're going to calculate its area using our formulas and then calculate population density. If you look at the picture shown, population density is, and if you look at these examples, you look at different regions, think of where you live in wherever it would be, wherever it may be. Do you think it looks like figure A, which is a suburb? I'm going to try to highlight this, so see if you can know what I'm referring to. This is figure A. Okay. Figure B is a rural area, more like farming area. Figure C, very, very congested area. Okay. And figure D, which there's nobody here. Now, if you think about the same amount of space, they're all squares, congruent squares, but some of them are more tightly packed with people than others are. So some of them are denser in population than others. Like for example, D has no one, and looking at C has a lot. The population is very large in comparison. So why would that matter? Why would population density be an issue? Like, who really cares, honestly? Well, real world applications such as funding for police, hospitals, teachers, parks, things like that. You need to determine funding based on the population density. If there's no people, we don't need to have as many hospitals, as many fire stations. Whereas if there's a lot more people, we have to have services to provide for those people. So that's like an example of where population density occurs in the real world. So let's go ahead and jump right into it. So consider these two regions here, Anchorage, Alaska. I'm not sure if you can see the picture. Look at the background so you can get an idea of the terrain in Anchorage, Alaska. And then on the right, you have Honolulu, Hawaii. That's a city in the island of Oahu, which is one of the Hawaiian islands. So remember, we're going to calculate the population density of both of these. Right now, we're not referring to the worksheet yet. I'm going to give you some general examples first. So if I ask for the population density of both of these areas, remember that I said the population density is the population, okay, the number of people divided by the area. So in this case, I'm giving you both. So the density would be, in this case, the population, 291,826 divided by 1,705. So if you divide that, 291,826 divided by 1,705, the population density of Anchorage, Alaska would be approximately 171.2 people per square mile. Make sure you always refer to the units whenever you're talking about density. Okay, now let's compare that to the population density of Honolulu. Again, the population density, as we said a second ago, is the population, 337,256, divided by the area. Okay, so a lot more people and a lot less space. Let's see what happens here. 337,256 divided by 61. Now we have approximately 5,528 0.8 people per square mile. So definitely a lot denser. And if you can look at the picture, you see there's a lot of buildings, so lots of stories with people congested in the same amount of land space, a lot more density, population density in Honolulu as compared to Alaska. Okay, now let's try some other examples. This is in your book on page 965, okay? So here we have the state of Nevada. So the state of Nevada, we're gonna calculate its population density. Formula, as I specified earlier, population divided by area. Now in this problem, in example 1, we are given the population, 3.1 million people, but we're not given the area. Okay, so this is why it's called modeling. We're trying to model using our area formulas and approximate the area of Nevada with a shape that we already know the area formula for. And if you look at the shape of Nevada, it mostly resembles a trapezoid. So we're going to use the formula for the area of a trapezoid to calculate the population density, approximate the population density in the state of Nevada. So again, using the formula for the area of a trapezoid, which of course we all remember, and it's on our EOC reference sheet as well, half times height times base 1 plus base 2. So this is the height. And then of course the bases are the parallel sides. So we're going to refer to this one as base 1, and we're going to refer to the other one as base 2. So plugging into the area formula, we calculate the area as 110,400 square miles of land in the state of Nevada. So now that we have the population, which we were given earlier as 3.1, and now that we have the area that we just calculated as 110,400 square miles, now we're going to calculate the density. So the population density would be the number of people divided by the land. And if you do that, you get 28. Don't forget, you always have to write the units in. I told you I'd be pickier about that, this moving forward. So the population density of the state of Nevada is about 28 people per square mile. If you've ever been to Nevada, there's lots of deserts, lots of, terrain that's not populated as much, and that's probably why it's such a low number. Okay, I think we are ready to do our first example on the worksheet. So if you look at the worksheet and refer to this one, very similar to the one that I just gave you, only this time we're going to do it on a coordinate plane. So if you look at this example, this is example 1B on the worksheet you should have in front of you. We're going to approximate the population density of the state of Vermont, okay? So if we think of the state of Vermont, which is on the left, I'm circling it right now. This is the state of Vermont, what it looks like. And it mostly resembles, if you put it up onto a coordinate plane, a trapezoid again, okay? So if we scale it down and try to calculate its area using the traditional formula, let's see what we're given. The state of Vermont has a population, identify the key information, of 626,000. Great, so we're good with the number of people. Check. Now we just need the area. So looking at it on the coordinate plane, again, we're going to refer to this as a trapezoid. So it looks like this is scaled. So we need to look at the scale and determine what the scale is. It looks like it's going in increments. Every increment is going in 20s, it seems, because it took 5 increments to get to 100 on both scales. So if you take 100 and divide it by 5, they are scaling this by 20. So keep that in mind as you're determining the dimensions of the trapezoid. So remember, it's 1/2 times the height times base 1 plus base 2. So the height of the trapezoid, it would be from here to here. So I'm counting this by 20s, 20, 40, 60, 80, 100, goes up to 160. So the height of the trapezoid is 160. Now the bases of the trapezoid are 40 for this one. Let's call this base 1. And the other one is 20, 40, 60, 80. 80, we're going to call that base 2. So plugging into the formula, 40 plus 80 is 120. 120 times 160 divided by 2. 120 times 160 divided by 2 is 9,600. So that is our area, 9,600 square miles. So now that you have the population of 626,000 people divided by 9,600 people, Be careful you don't lose any zeros there. The population density of the state of Vermont is approximately 65.2 people per square mile. Okay, so write that down. If you need to pause me, and then we can continue. Okay, moving on to our next example. This one is also on your worksheet, very similar. Calculating the population density of the city of Chicago. It's my hometown. Yay. No, actually, I consider Miami my hometown, but I was born in Chicago. Okay, so population is 2,715,000. Great, we got the population, but we need the area. So if you look at the coordinate plane here, this mimics a parallelogram. So we need to find the area of a parallelogram to approximate the population density of Chicago. Okay, remember that the area of a parallelogram formula is base times height. Let's determine the scale here. It looks like it took 5 increments to get to 25. So if we take 25 and divide it by 5, the increments are 5. So let's go ahead and calculate the base. The base here would be 2 units, so that's 10. And then the height would be 5, 10, 15, 20. So this is my height. This is my base. So the area would be 10 times 20, which is 200. 200, and it tells you here that each unit represents 1 mile. Okay, so 200 square miles is the approximate area for the city of Chicago. So now the population density would be, again, looking at the formula up here, 2,715,000 divided by 200. So doing that on our calculator, I get approximately 13,575 people per square mile in the city of Chicago. Okay, so I think we're ready to move on. Okay, bless you. Okay, next one. This one is a circle. So this is, we're doing circle area. Let's go ahead and do the area of a circle. So on this one, it says about 58,000 people live in a circular region with a 2-mile radius. Find the population density in people per square mile. Okay, again, so the population density is the people, or the population in a certain area. So we have the people here. The people are 58,000, so we're good there. The problem is that we don't know the area, but we are told it's a circle. So let's go over here, sidebar. Let's go ahead and calculate the area for the circle. So the area is pi times radius squared. So it's going to be pi times 2 squared. We're told the radius is 2. So that's going to be 4 pi. 4 pi, and I give it to me in miles, so that's square miles. You can leave it exact if you like. Okay, go ahead and use 4 pi here for your area, plugging in. Okay, now remember what I told you guys the other day about when you're dividing by a quantity that has pi. When you're typing this into your calculator, you have to tell the calculator that you're going to put 4 pi in parentheses. To do that first, and then it'll divide 58,000 by that amount. So on your calculator, we're going to do 58,000 divided by parentheses 4 times pi close parentheses equals, okay, and that's going to give you approximately 4,615.5 people per square mile. Okay, so I've given you an example with a trapezoid. I've given you an example with a parallelogram. I've given you an example with a circle. Okay, so let's try the next thing. Okay, the next thing that we're going to do is look at an example where maybe we are given the population density and one of the other items is missing, like say maybe the number of people are missing, maybe the land area is missing. So let's see how we would approach something like that. It's actually very simple. All you would do is you write down the formula, plug in what you know, and solve for what's missing. So in this example, which is not on your worksheet, but I just want you to look at this one first, okay? So this is a town in California, and they're giving me the density. Okay, they're giving me the area, it's the population that's missing. Okay, so again, I'm gonna write down the formula. I have the formula first. Always write down the formula first. Plug in what you know, and then you work backwards. So we're given the density as 778. Okay, the population we don't know, so I'm gonna call that X. And the area I am given as 10 square miles. Okay, like I've always taught you, you can treat this like a proportion and cross multiply. You can multiply both sides with a denominator, it doesn't matter. However you handle this, 1 times X is X. 778 times 10 is 7780. So 7780 is the population. So go ahead and write the unit for the answer. 7,780 people is my population. Okay, let's try the next one for Lincoln, Nebraska. Now the area is missing. So don't forget the density is equal to the population divided by the area. They're giving me the density down here. So 2899. Now the population is given to me also as 258,379. What I don't know is the area. Okay, let me just call that A for area. So I need to solve this for area. So I'm going to cross multiply. So it'll be like I've always taught you, you put a 1 down here. You can do it other ways, however you're more comfortable with. So it's when you cross multiply, 2899A equals 258,379. Now we're going to divide both sides by that 2899 number, 2899. So if you do that, you're getting the area is approximately 258,379 divided by 2899, and you're getting 89.12. So 89.12. Now it's area, the units are miles, so square miles. And that's my answer for that one. Okay. Now I'd like you to try one where something is missing. If you look at the worksheet that I gave you, look at question number 6. Question number 6 is one of those where you have to work backwards to find what they're asking for. Okay, so you can pause me and then play it again when you're ready. Okay, here's the answer. So first things first, what is missing in this question? How large? So it looks like they're asking for the area. So again, the formula for population density, the density is equal to the population divided by the area. So they're giving me the density as 111,002. The population is 1652171, and it's the area that I'm missing. So doing it like the example that I just gave you, if you cross multiply, it'll be let me go back to blue. 111,002A equals 1652171. And now we're going to divide both sides by the 111002 number, 111002 number, and then, so on your calculator, do 1652171 divided by 111002 is equal to, I get about, it says to the nearest 10th of a square mile, that means 1 decimal place. It's about 14.9 square miles. And that's the answer to that question. Okay, so in summary, today I showed you how to do population density. Remember the formula is population density equals people or population in a certain amount of space, usually area. We're going to be talking about different application of density once we get into 3D shapes. But that should be enough now for you to go back and do the the rest of the examples in the worksheet that I gave you for class. And the answers for those are on my website at the bottom. It's one of the files, so you can check your answers against those. And then go and do the exercises from the book, okay? That's one of your homework assignments. I'm gonna go ahead and put a 3D vocabulary chart to prepare you for what we're doing next week. If you can start getting those vocabulary words that you need from chapter 12, or you can use the glossary or the back of the book. The substitute has those vocabulary charts. Just go ahead and ask her to give them to you, or it's also on my website. And then don't forget that your EOC review number 2 that was assigned a while ago is due on the next time I see you as well. Okay, so until next time, bye.